So I'm looking at first year maths here, geometry 1, and we're looking at angles and parallel lines. Now parallel lines you'll probably have met in primary school. So parallel lines are two lines that are never going to meet each other. They go on for forever and ever without hitting each other. Imagine train tracks. The actual tracks are parallel lines. They're denoted as L, and two vertical lines that you can see are parallel, and then M, where L and M are just the names of the lines. The lines could be K and S, and then you would say K is parallel to S. Okay? And on a diagram we denote it by two arrows facing the same direction. Then we come across something that you wouldn't have met in primary school, is corresponding angles. So all of these lines here you can see are parallel to each other because they all have that same arrow going the same direction. So they are parallel. This line here then is called a transversal. A transversal. A transversal crosses the parallel lines. Okay, so a transversal is a line that crosses parallel lines. And what gets created are corresponding angles. So just as a fact, I know that all of these angles are the same. So corresponding angles are equal in measure as a fact. And corresponding angles can be found when a pair of parallel lines, as I have here, are crossed by a transversal. Okay. Similarly, all the way down here, we have lots of pairs of corresponding angles because I have all these parallel lines. Then I can say that this angle is corresponding to this angle here. This angle here is corresponding to this angle here. This angle here is corresponding, and these angles here are corresponding. You might have noticed there as well that I have done two dots for these angles, one dot for this angle, one line through the angle here, and two lines through the angle there. They are just four different ways in which we can say they are equal to each other. Similar to corresponding angles are alternate angles. So alternate angles, again, are when parallel lines are formed and we have a transversal across them. We can see that there is a Z shape formed, and the angle here is equal to the angle here. They are called alternate angles. Again, I have parallel lines, a transversal across it, and a Z shape is formed. Now it's a funny looking Z shape, but it is a Z shape. That these are alternate angles. So people confuse alternate and, so here's the fact, I suppose, the important note that alternate angles are equal in measure. So people confuse the fact, the difference between alternate and corresponding. So alternate and corresponding, and what shapes they actually make. I like to remember that an alternate makes a Z shape, and the way I remember that is A is at the start of the alphabet, Z is at the end of the alphabet, so I think they bookend the alphabet. And then I remember corresponding is just going to be the other shape. Now I haven't mentioned that corresponding makes an F shape, so I'm just going to go back and look at the correspondings, and you will see here there's an F shape. Here there's a backwards F. Here there's a backwards F and it's upside down. And here there's an upside down F. So corresponding angles make an F shape, where alternate angles make a Z shape. The final thing then to note is interior angles before we look at any example. And interior angles are just a way of describing a pair of angles that are formed when we have parallel lines and a transversal. The interior angles are the angles that face each other. So this angle here and this angle here add up to 180 degrees. Interior angles add up to 180 degrees. Similarly here, and here. Those two angles, the two red angles, will add up to 180 degrees. So you'll see that when I come along to an example. So question 1 here, in each of the following diagrams, write down the number of the angle that corresponds with the shaded angle. Okay, so I'm corresponding. Is that a Z or an F shape? It'll be an F shape. So I have my parallel lines and I have my transversal across it. So where is the F shape formed? It's formed with the 5. Down here then, I want an F shape again. So I have my transversal across it and parallel lines. It's going to be the number 4 that gives me the corresponding. And what about this one? I have my transversal, my parallel lines. Where's the F shape formed? It's formed with the number 6. So write down the size of the angle marked with a letter in each. Well, how about this question here? I know when two lines hit each other, two straight lines cross each other, that they form a pair of angles. That this angle here is equal to this angle here because they are vertically opposite, as we met yesterday. So E is going to be 65 degrees, and I should write down the reason. It's because they're ... vertically opposite. Okay, so if I know this is 65, and I know I have a parallel line here and a parallel line here, what shape is just become visible? It is a Z shape, and Z reminds me of the end and the start of the alphabet. So that's going to be 65 degrees as well, and because it is alternate angles. So find the size of the lettered angles. The last note that you took down, we know it's a straight line, straight parallel line, and we have a transversal across it. So what do I call two angles that are facing each other there? They're interior angles, so B is going to have to make 110 add up to 180, so B is equal to 70 degrees, okay, and that's because they're interior. What about A? Well, I know B and A form a straight line. B plus A is equal to 180 degrees. Straight line. But I know B is equal to 70, so 70 plus A is equal to 180. So A is equal to 110 degrees. Weirdly, I suppose, with the last question here, it's important to note that we have parallel lines there. So we have a transversal as well. So you might spot a certain lettered shape there. We have an F shape. So I know that G and F here are equal to each other. I also know that I have the angle G is equal to the angle F. And we also know that we have a triangle then formed here. And what do I know about a triangle? The angles inside a triangle must add up to 180 degrees. So the angle G, and I should have labeled all of these as the angle A and the angle B. The angle G plus 36 plus 72 is equal to 180 degrees. So the angle G is going to be 180 minus 72 minus 36. What's that on the calculator? Minus 72 is 72 degrees itself. So G is equal to 72 degrees. F is equal to G. And this is again, why is this? This is because they are corresponding. And it's important to write down that reason that they're corresponding. I should write down the reason here. Angles in a triangle sum to 180. So we know that the angle F is equal to 72 degrees. And the dog's barking. But the good news is that she scared off the postman. We know that we have a straight line here. So that means 72 plus E and plus F. 72 degrees plus the angle E plus the angle F is equal to 180 degrees. Straight line. So that's 72 degrees plus E plus 72 degrees is equal to 180 degrees. So we just need to take 72 away from 180 twice. Minus 2 times 72. 36 degrees is the angle E.